Hello again, this is Mrs. Bokerman. So we just graphed some cardioids, so now we're going to graph some limacons. No, they're not limacons. It's a very French word, limaçon. Okay, so this is where you have different numbers. So the polar equation looks very similar, except with the cardioid, you have a 2 and a 2 or a 3 and a 3. Here you have different numbers. So similarly, I started out with graphing what it looks like in rectangular. So you can kind of get a sense of what it would look like in the polar graph and how they relate. So similarly, you can always make a table of values. So let's start there with this. So if I plug in 0, then I would have 1, and 1 plus 2 is 3. If I plug in pi halves, I would have 0, so I would have just 1. If I plug in pi, though, I would have -1 for cosine. So then 1 minus 2 would actually be a -1. So this is the first time in our table where we actually have a negative radius. So think about how you're going to graph that. It's going to be kind of important. Okay. And then if you keep going on the table, you should get a 1 and a 3. So in the 0 direction, I would go out to 3 on my polar grid. In the pi over 2 direction, I would go up 1. But then if I'm looking in the pi direction, if I went out 1, that would be going positive. So to go -1, I actually have to go negative, which would be going towards 0. Okay, so what happens is this negative right here actually generates this, what I call loop-de-loop. Okay, but what's happening is there is a whole bunch of values, if you think about the rectangular graph, where we are actually now in the negatives. Okay, so what happens is that creates this loop here. So these angles there, as well as these angles from just after pi over 2, you could see I'm still kind of in the positive, but at some point, these values in here are all negative, which is what creates this loop. Okay, so the order that it's going to graph is it's actually going to start over here, come up to pi halves, still be in the positive for a little bit, and then it's going to loop this way and then down this way, and then continue around to 0. Okay, and the order in which things graphed is really beneficial for BC calculus and AP calculus. Not so much in this class, but I did want you to kind of understand what was going on. There's a whole range of values that are negative, and so these sides would be positive, but then if you want to graph the negative angles, that's what creates that loop. Okay, hopefully you're not surprised that it's a cosine graph and it's symmetrical along the polar axis. Okay, but there's a little similarity between limacons and cardioids, which is why we kind of did them together. Okay, I want you to think about the distance that it went out, as well as the distance of the loop and the distance to the side, and see if you can figure out the relationship going on there between these numbers. Okay, let's try one more. If I wanted you to graph 2 minus 5 sine theta. Okay, now again, since you're new to this, you could make a table of values, although I do want it to be obvious that it's a sine graph, so it should be symmetrical along the pi over 2 axis. The negative will just mean that the long part of this will be facing down. Okay, if it was positive, it would be facing up. So if you think about it, if I plug in 0, this is gone, so my side is just 2. So the distance to the side, similar to a cardioid, is this number A in front. Okay. Now this went out to 1, 2, 3. I wonder how we could have gotten a 3 from a 1 and a 2. And the loop was a 1. I wonder how we could have gotten a 1 from a 1 and a 2. Okay, so similarly, we have 2 and a 5, and this is what it should look like. Okay, a couple things I want to point out. Again, the distance to the side, this is 2. Okay, that is the same as that number there, because when you plug in 0 and pi, that totally goes away. So that's why it's just that number. Now, the other thing is this big distance goes all the way to 7. How could I get 7 from 2 and 5? Similarly, the length of the loop is 3. Okay, hopefully I'm making that obvious to you of how I could get those numbers rather quickly. Okay, but I also hope that you're questioning, well, is there always going to be a loop? Okay, so I want you to notice that this is 1 and then 2. as well as a 2 and then a 5. And so the obvious thing I want to point out is the first number is actually smaller than the second number. Okay, so what if I were to switch it? What if I were to have a 2 and then a 1 and then a 5 and then a 2? Would it be the same thing? Okay, so now we have a 3 and a 2. We've switched it. Okay, now I have a cosine graph, so it should be symmetrical along the polar axis. And the same thing can apply. I can make a table of values. Now, what happened to the loop? Well, the obvious thing I want to point out is notice in your rectangular graph, there is nowhere where your radius is negative, where it goes below the x-axis, because the first number is bigger, that this number minus this number is never going to be smaller than 0. Okay, so instead of a loop, it creates what we call a little dimple. So you could have a limacon with a loop, or you can have a limacon with a dimple. Okay, couple other things though. Notice the distance this way goes all the way out to 5. The distance to the side went out to 3. Okay, now this is what we call the length of the dimple. This is 1. Okay, notice it does not go in the same direction because at 0, I need to go to a length of 1, not -1. So there is no loop. Okay, so you have two types of limacons. You have a limacon with a loop and a limacon with a dimple. Okay, so let's kind of look at one more graph. Okay, if I wanted to graph this rather quickly, I have a 5 and then a 1. So this is going to create a dimple. If it was 1 and then 5, it would be a loop. Okay, it's a sine graph and it's positive, so it should be facing up. Okay, so on either direction to the sides, this would be gone and my length would be out 5 in both directions. The long part of it I would add these two numbers together. 5 and 1 is going to make 6. So notice that happened. From here to here, we did a length of 6. To either side, we went 5 because the sign of 0 is 0, so that's gone. And then the dimple part of it is you want to actually subtract those two numbers. So this one doesn't really look like a dimple because the numbers are kind of larger, but this would be a dimple of 4. Okay, so let's add that to our summary so you can kind of get it together. Okay, so a limacon with a loop is when you have a minus b. The smaller number comes first. A limacon with a dimple is when your larger number comes first. Okay, notice it's just not the same number. That's the only difference in cardioids. Cardioids have to be a 2 and a 2, a 5 and a 5. Limacons are any combination of numbers. Okay, it doesn't matter if it's sine, it doesn't matter if it's cosine, and the positive and negative just tells you what the long side is. Okay, so the length of the long side, you're going to add them together. And we're saying absolute value because you should know where it should go based on if it's positive, negative, and if it's a sine or a cosine graph. The length of the loop is a minus b. Okay, and so that you're going to add them to get the long length and you're going to subtract them to get the short length. And then the length to the side is still a because at some point these are 0 and so they would be gone. Similarly, with the dimple, the length of the long side is you add them together. The length of the dimple is you subtract them. It just doesn't go in the same direction. It goes in the opposite direction. And then the length to the side is just a. So I put this together, and you can pause the video if you want to write that down. And I put this together to kind of help you out. Okay, you should be able to look at any of the polar graphs and know if it's a cardioid, a limacon with a loop, or a limacon with a dimple before you even start, based on the numbers. Okay, so a loop is going to have the smaller number first. The length to the side is going to be this a. The length of the loop, you're going to subtract them. And the length of the long side is going to be a plus b. Okay, so notice I have a 2 minus 5, and then I have a 5 minus 2. Same thing, except now this one has a dimple. So the long side is going to be 5 and 2 is 7. The dimple is going to be 5 minus 2, which is 3. And the length to the side is both 5. Notice these lengths are all from the pole, not the whole distance. So it's not saying from this point to this point has to be 7. The length from the pole has to be 7. The length from the pole over here had to be 7. Okay, so hopefully that kind of helps. So those are cardioids and limacons, very, very similar. It's all on just which number comes first. And now you can do your Math Excel homework.